All right, in this video, we are going to be talking about P-series. This one is one of the easier tests that we are going to be looking at. In this case, you have a series that goes from 1 to infinity, and it's in the form of 1 over n to the p power. Your series will diverge when p is between 0 and 1, and it will converge when p is greater than 1. If p is exactly 1, it diverges, and it has a name for it, which is a harmonic series. So if you have 1 over n, you have 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4, and so forth. These examples right here, you will see that they're not the same thing as this right here, where it's in the form of 1 over n to the p power. We actually have to make it so that it looks like that. So we're going to have to use a little bit of algebra. I know. Number 1, we kind of did this already using the integral test, which was kind of a mess. So lucky for us, we have a little shortcut, aka the P-series test, and this is going to help us. In this case, I want to make sure that it looks like n to the p power, and then we're going to see if the exponent is greater than 1, or if it's between 0 and 1. Okay, this can be rewritten as n is equal to 1 to infinity, and then this is going to be equal to, let's see, 3/2. Because I have 3/2 right here, this tells me that the series will converge because it is greater than 1. The series will converge by the p-test. Given that we have learned like 4 or 5 tests so far, it's important to note what test we're using. In this case, we're using the p-test. Same thing with number 2. I'm going to try and rewrite this so that I have n to the 2/3. Now, because 2/3 is between 0 and 1, the series will diverge since it's less than 1. Number 3, same process. We have 1 over pi. Now, 1 over pi is definitely going to be between 0 and 1, because that's the case. The series will diverge by the p-test, which I forgot to turn on the other one. Okay, number 4, you'll notice that here we could split this up into 2 parts. Notice how my exponent here is 3 and my exponent here is e, and since both of them are greater than 0, this means that this will eventually converge and this will eventually converge. Since both of them converge, this tells me that my whole summation right here, my whole series, will converge. So this right here converges by P-series test. Now, you'll notice that with 1 through 4, we don't necessarily know what the summation or the sum is. The only way we could do that is using Wolfram Alpha or something like that. So the only 2 tests where we can actually find the sum will be the geometric test and then the telescoping test. All right, number 5, same process. Try to make it look like one over n to the p power. Because 3/2 is greater than 1, this tells me that I am converging. This is convergent. Number 6, you kind of have to find the rule for this. You'll see that here I have 1, 1, 1, 1, 1, 1, 1. And then here I have 1, 4, 9, 16, 25, which is just plot twist and square. And since 2 is greater than 1, we know that my series will converge. All right, number 7, we want to find values of p for which the series converges. Remember that it converges whenever p is greater than 1. So what I'm going to do here is make sure that I move this to the bottom. So I have 1 over n squared n to the negative 3p minus 1. Simplify that a little bit. 1 over n to the negative 3p plus 1. My exponent needs to be greater than 1. Oops, not 0, 1. For it to be convergent. Negative 3p is greater than 0. And then if I were to flip, because I'm divided by negative 3, this tells me that p has to be less than 0 for the series to converge. All right. 8, 9, 10, and 11 is basically a review in terms of geometric, integral, nth term, and all of that good stuff. Telescoping, who knows? So for these are good reviews in terms of preparing you for the test, because you got to figure out which one goes with which I'm not going to do, but you can.